Currently, Llama 3.1405 billion has set a new standard for open-source large language models. It demonstrated new abilities we previously thought were unattainable, and it has conclusively shown through numerous benchmarks that open source can indeed match the capabilities of closed-source AI, at least in the case of GPT-4 Omni. Today, Mistral responded by unveiling what they refer to as Mistral Large2, describing it as sufficiently large. This represents another significant advancement, featuring a model with 123 billion parameters, which is less than half the size of Llama 3.1405 billion. Remarkably, in my view, it nearly matches the performance of the largest Llama 3.1 model and emphasizes areas that I believe are perhaps more crucial and relevant. Today, particularly for agentic applications and those seeking to run open-source large language models on a single GPU, the major breakthrough is that this model is designed to operate in full precision on a single H100. You can actually do this now without requiring an elaborate local Mac Studio cluster or a multitude of GPUs. It also supports multiple languages, handles coding straight away, and incorporates enhancements from Mistral and Codestral that we observed last week. Although this model is transformer-based, there's much to explore here. I was genuinely surprised by today's release. Clearly, Mistral has been rolling out a lot of significant updates to their models and research recently. Admittedly, Meta's release of Llama 3.1405 billion has been highly anticipated for months, and there was uncertainty about whether it would even materialize. If there's ever been a moment to demonstrate that open-source AI propels other open-source AI to improve, continually challenge, and redefine what constitutes state-of-the-art and a frontier model, this is it. Let's dive into Mistral's take on this new frontier model, which I think stands out on its own. Before we dive into today's video, if you're interested in a one-on-one consultant call with me, you can book one using the link in the description below. While Llama 3.1405 billion remains the top performer at the moment, this new model, being roughly a third of its size, is truly remarkable. However, it's important to note that this model isn't fully available for commercial use, yet it's primarily intended for research purposes, which is a key distinction from the other meta models. Similar to Llama 3.1405 billion, this model has a 128,000 token context window and supports several dozen languages right from the start, as well as nearly 80 coding languages. What I appreciate about Mistral is their clear delineation of what this model is intended to do and what it's not. Another exciting aspect is Mistral's commitment to their focused model approach. They specify that Mistral 2 is built for single-node inference with long context applications in mind. The 123 billion parameters enable it to achieve high throughput on a single node, which was a deliberate design choice. This also means it's cheaper to fine-tune, cheaper to iterate on, and generally more affordable to operate. Mistral also aimed to set new performance records with this model, particularly in terms of cost efficiency in serving evaluation metrics and achieving faster benchmarking. Many people might not realize that a significant reason for the delay in benchmarks following releases is the considerable expense involved in re-benchmarking all these models across the various existing benchmarks. Additionally, these benchmarks need to be replicated sufficiently so that the results are reliable. Code and reasoning are central to this model, with agentic applications being a top priority for Mistral during its development. We've seen impressive releases from Mistral in the past few months, including Codestral 22 billion and Codestral Mamba, each of which brought unique innovations. But Mistral appears to have learned from these models, despite Codestral Mamba featuring a completely different architecture. They mentioned that Mistral Large2 was trained on a substantial amount of code, highlighting their focus on enhancing code-related capabilities. The Mistral Large2 significantly surpasses the previous Mistral Large in coding capabilities and is essentially on par with GPT-4 Omni, Claude 3 Opus, and Llama 3.1405 billion. It's crucial to note that while Llama 3.1405 billion excels as a powerful instructive model, it isn't necessarily a frontier coding model. In terms of coding, Mistral maintains a slight edge and Claude 3.5 remains the best in this area by a considerable margin. When examining code generation and math performance, Mistral Large2 significantly outperforms Llama 3.170 billion, which many anticipate will be the most utilized and fine-tuned variant of the latest Llama models. It's notable that Mistral Large2's performance is not only better but also well beyond what could be considered a margin of error, establishing a clear advantage in these areas. Another key area of focus was enhancing the model's reasoning capabilities, specifically to reduce its tendency to hallucinate or generate plausible sounding but factually incorrect information. Interestingly, Mistral Large2 was fine-tuned to be more cautious and discerning in its responses. This model is designed to acknowledge when it cannot find a solution within a given confidence interval, either defined by the model itself or specified by a user. This commitment to accuracy is a notable approach, as it steers the model to prioritize reliability, a characteristic usually associated with instruct models. This is particularly intriguing given that Mistral Large2 isn't primarily described as an instruct model, which underscores a broader application of such cautious and accuracy-focused tuning outside the typical instruct model framework. It's impressive to see a live comparison between Mistral Large and Mistral Large2 across various benchmarks, including human evaluation and more advanced assessment. While Mistral Large might not top the charts, the degree of improvement in Mistral Large2 is indeed striking. I've always advocated that the rate of improvement in models is more intriguing than mere raw benchmarks on release day. This perspective highlights the dynamic progress in AI development, particularly in areas like code generation, where Mistral Large2 shows substantial advancements. But this progress is not only a testament to technological evolution, but also to the potential for future enhancements in model capabilities. What's fascinating is the variation in performance preferences among these models across different programming languages. Specifically, Mistral Large2 excels in C, Bash, Java, TypeScript, PHP, and C. Bash is notable for its general use in Linux operations, while Java's prominence likely stems from its extensive training set, second only to Python. It's intriguing that Python isn't mentioned here, but Mistral Large2's superior performance in Java, an object-oriented language, suggests it handles the complexity of such languages well. I'm currently working on a benchmark comparing object-oriented and functional language performance between models. Let me know if you'd like more details on this. It's indeed fascinating to see how different models specialize in various programming languages. Llama 3.1 405 billion performs best with Bash and C, which is particularly interesting. Meanwhile, GPT-4 Omni excels in TypeScript and PHP. The focus on TypeScript by GPT-4 Omni aligns well with OpenAI's likely hiring trend towards web developers, anticipating their primary user base. Moreover, given their affiliation with Microsoft, which significantly contributes to the TypeScript open source project, GPT-4 Omni's prowess in TypeScript isn't surprising. The absence of comparisons with Claude 3.5, arguably the current top performer in coding among large language models, is notable and perhaps strategic. Claude 3.5's omission might suggest it still leads in coding capabilities, a point that many in the AI community, including myself, might argue in favor of. This nuanced view of each model's strengths adds a rich layer to understanding how AI capabilities are evolving and being tailored to specific programming environments. Instruction following and alignment are crucial areas, particularly for agentic tasks, and Mistral Large2 was specifically designed with these applications in mind. When smaller, quantized versions of Mistral Large2 are released, I believe their value for agentic applications will far exceed that of Llama 3.170 billion or 8 billion quants. This is primarily because Mistral Large2 requires less upfront work to ensure compliance and accurate response generation. So this streamlined alignment process makes Mistral Large2 more efficient and effective as an individual agent right from the start. Ensuring that agents can admit uncertainty or recognize when they are wrong is crucial, especially in agentic workflows. If an agent in a workflow sequence doesn't honestly acknowledge when it might be providing incorrect information, it can disrupt all subsequent outputs from other agents. By having agents accurately identify and signal the need to rerun or revisit a step, you can achieve more accurate and dynamic outcomes. Agentic workflows are still in their infancy, with no established standards yet, making it an exciting area to watch for future developments and innovations. Another interesting aspect is Mistral's understanding of user expectations with large language models, LLMs. Some believe users are willing to wait for highly accurate responses, but a significant reason GPT-4 Omni impressed was its ease of interaction. It provided quick, sharp responses similar to the enjoyable experience of using Midjourney for the first time, where results came back in just a few seconds. This quick feedback loop is highly appealing, as people generally prefer interacting with models that are responsive and efficient, delivering prompt and engaging interactions. In this model, prioritizing shorter generation times not only enhances user experience by facilitating quicker interactions, but also makes it more cost-effective for inference. This dual benefit underscores the efficiency of the model. The MT Bench results also highlight these advantages, showcasing Mistral Large and Mistral Large2 as strong performers. Claude 3 Opus and Sonnet are also mentioned in this context, indicating their relevance in the landscape. However, Mistral Large and Mistral Large2 continue to secure significant wins, demonstrating their robustness and appeal in delivering fast and efficient outputs. It's indeed impressive how these models handle multiple languages. Even if you primarily use English and French and are just starting to learn Chinese, these multilingual capabilities represent a significant incidental benefit of the performance improvements. It broadens the accessibility and applicability of these models for users worldwide, enhancing their versatility and usability across different linguistic contexts. It's exciting to see the availability of this model across various platforms, including local setups, if you have the right hardware, and cloud services like Azure AI Studio, Amazon Bedrock, and even IBM. This widespread availability opens the door for some fascinating integrations, particularly with platforms like Hugging Face. The most exciting aspect of this model is its native support for function calling and its tuning for agentic functionalities right out of the box. The ability to run the entire model on a single H100 node is impressive, making it accessible and efficient for a wider range of applications. This feature, coupled with its advanced capabilities, makes it a standout choice for developers and researchers looking to leverage state-of-the-art AI technology. While Llama 3.1405 billion excels in tasks like writing and long-form content, Mistral Large2's responsiveness and versatility in various tasks make it a strong contender. The comparison between Mistral's models and Meta's latest releases is intriguing, especially in the context of open-source AI. Mistral's focus on responsiveness, efficiency, and versatility with models like Mistral Large2 offers a compelling alternative to Meta's offerings, which have traditionally been more focused on robustness and handling a broader range of tasks. Like long-form content creation with Llama 3.1405 billion. As for which represents a better version of open-source AI, it depends on what criteria you're prioritizing. Mistral's models seem to be geared towards efficiency and specific applications, such as agentic functionalities and function calling, making them highly practical for certain use cases. Meta's models, on the other. The advancements we've seen are indeed incredible, and it's great to share this enthusiasm with your audience. If you enjoyed this discussion, don't forget to like, subscribe, and share, and stay tuned for more insightful content in the next video.